Hi. So my name is Benjamin. I'm a software engineer at Nevoda. Nevoda is an agency based in London. We do Android development and only that. And we try to do our best. You can find me on the usual Twitter, Google+, GitHub. And let's start the talk. So RxFy all the things. So the first thing I want to address is why. Why should you even care about what I'm going to say right now? I would say because we've all experienced problem with concurrency. It's a tough issue. It's something that is quite difficult in our job because usually we want a way to structure our thought process. We want a way to help us design small and reusable piece of software, functions as small as possible to be able to test them, reuse them, and exchange them. And just really because development is hell. A quick show of hand. Who here had to deal with, let's say, questionably designed APIs? A fair amount of people. Who here is dealing on a daily basis with changing requirements, like every single day, new stuff coming in, completely breaking everything you thought about? Yeah, same. The vast majority of us. And it's true. It's what we do every day. We have to fix problems. That's what we're paid for. We're here to take a requirement, make it true. And things change. Nothing is set in stone. We usually have to deal with third-party APIs, multiple sources of data, be it sensors, APIs, local user interaction, whatever. We have to deal with all those sources of data, and we have to constantly change the way we interact with them. And that's difficult. So what is RxJava, and how can it help you? So RxJava is an implementation of the pattern Observable Observer. It's not new. The concept of reactive programming is pretty old. It's all inspired by the Reactive.NET extensions that are probably around 10 to 15 years old now. So it's not something new, but it had a big boom in the past few years. A lot of people are getting interested in porting those concepts to multiple platforms, multiple languages. And there's a reason for it, because it can really help you. So what is it? An observable is something that is asynchronous. Who here has heard of futures? Good. So a future is the idea that we have a value that is not there yet, but might be there in the future. If I want to fetch something from an API, I don't have a response right now. I could block and get it straight away, which is getting data. It's the synchronous way. Or I could just say, I'm going to return now. Something is going to happen, and one day you'll have a value. You could attach callbacks to it, or there's a different way of implementing it. And an observable is the same concept, but similar to a list. It's a collection of futures. It is something that is representing multiple future values. So you can think of it as something that is going to emit between 0 and n values. It's something that's going to emit multiple values over time, and it might emit 1, multiple, 0. At one point, it might terminate, saying, I'm finished, I'm not going to send you anything anymore, or it might fail. And that way of representing data is so generic that it could almost apply to anything. You can always think about something as being either the absence of something, an error, or a collection of values. On the other end, you have the observer. And you can think of it as like a typed listener. It's something that is going to register to an observable saying, hey, I know what to do with your values. I want to know when you have a new item, a new value. I want to know when you complete. And I want to know when you have a failure. Usually, this will sit at the end of your pipeline. So on Android, that would sit probably in your activity. And this is a place where you would grab the data and then decide to display it. So there's a lot of really, really good resources on RxJava, including a really, really good documentation. It's actually now unified along the reactivex.io, which is a website that is not only documenting RxJava, but also all the other Rx libraries existing today. It's a unified effort to make sure that if you understand one, you understand all of them. They're going to use the same naming convention, the same operators. The idea is really, if you know one of them, you can use it everywhere. So I'm going to use some of the notations I've been using in that documentation to try and explain the few basic concepts before we go into a small practical example. So they're using some schematics, and this is how they represent an observable. You can think of it as a timeline. So the arrow represents the time going from now to the future. And each of the shape is one value. So if you have an observable that would, I don't know, observe an article, you could think of each one of those shapes being a new version of that article. As in, it's a new value being emitted through the pipeline. The vertical line here means it's terminated, I'm finished, I'm never going to send anything to you anymore. And you can apply transformations. So in here, I take an observable, I transform it using flip, and that gives me a new observable. And this new observable emits values, which have been transformed in here, flipping each one of them, until I might have an error. And a cross is how you represent a failure. This notation sometimes takes a bit of time to get used to, but it's a really nice language-agnostic way of representing data and representing behavior of those operators. And there's a huge collection of those. It's reactive extensions for a reason. It's extensive. You have a lot of different small extensions, operators, transformations. But we're just going to see 3 of those today, which I think are probably the one you use the most. The first one is map. If you've ever done any functional programming before, this is fairly common to you. If not, it's fairly simple, really. Map says you give me a function that goes from a type, a circle, to another type, a square, and I'm going to apply it to every single item that is fed through. So you go from an observable to an observable of the transformed value. So if you had, I don't know, an observable of ints, and you apply map of times 2, then in here you just have 1 times 2, 2, 2 times 2, 4, and so on and so forth. It's a way to say, I know how to transform my data, so for each element that you're sending me, I will transform it. You can use it to convert JSON into objects. You can use it to do a lot of things, as long as you have a mapping between one object and another. The second operator is about composition. Flatmap allows you to say, for each item that I receive, I know how to provide another observable. So for this one, it's nice to think about the observable as a potential action, let's say an API task. You could say that when I get the result from one API task, I want to execute another API task and get the result. So this will allow you to compose different actions together and chain them and get the results at the end. And the last one is on error resume next. And this is an operator that allows you to say, if I get a failure, I might be able to know how to resume from it. I might know how to be able to restore my state and continue to work without having to bubble up the error to the UI. This is really powerful because it allows you to say, let's fail fast, let's fail for the things that I know, and then I can recover from that state, and I can deal with it without having to nag the user or nag the UI to have to deal with all those different potential failures and how to restore from them. So you try and keep the data in the data layer and just keep the UI simple. So in this case, this is only invoked when an error happens. And in here, you can see that you still have the original values, but when an error happens, you start executing what you provide. The second aspect of RxJava is, as I mentioned, concurrency. And part of concurrency is where do you execute things? So where do you execute things? Actually really easy. You just say subscribe on and provide a scheduler. And this will define where you execute all your work. All the work in your pipeline is going to be done within that scheduler. On the other end, you also have observe on, passing a scheduler as well, which says, once you've finished doing all your work, please deliver the results in another scheduler. Perfect for us on Android. We can say, please execute all the work in a thread pool executor, and then deliver the results on the main thread. And that's it. You have your pipeline doing work on the background, delivering results on the main thread. So all that, it's nice. It's just extremely abstract, isn't it? So let's take a concrete example and walk through it. So let's imagine that you have to write a fairly simple application that has to talk to a server. Let's build a shopping application. You have something that scans a barcode. You send the barcode to the API, and you need to add things to the basket. Fairly simple. Building a shopping list, basically, by scanning barcodes. So all is starting well. I mean, it's a simple API. I'm adding to the basket, passing in a barcode, and I have my updated basket back. It's perfect. I could even do an async task. Like, I have my setup, I execute something in background, and I get my post execute. What's wrong with that? Nothing right now, except 4 months later, when it looks like that. Yeah, we don't want that. So what can we do? Like, how can we make sure that we have the ability to refactor without having to spend 3 hours, 4 hours, 6 hours every single time a new requirement comes in? We want to be able to iterate fast. So how would you implement that simple first case using RxJava? You implement an observer of a basket, so a typed listener, that would sit in your UI, in your activity, and you say, if I get a basket, I update my UI. If I get an error, I can display dialog for it. If I complete, in here I don't really care about it right now, but technically you could even have a way to say, if you complete, you need to go to the checkout process or other behavior. Let's just focus on updating the UI by adding items to the basket. So that's fine. And your data layer. How do you create your observable in your data layer? So I'm not going to talk exactly on how you create it. It's fairly simple. There's loads of really good talks about it. And if you use something like retrofit, for example, for your API calls, it's even doing it for you. If you put this as a method in your API and your interface for retrofit, returning an observable of something, retrofit wraps it for you and already generates the observable. So you have your data repository, your data layer, that exposed to the UI, add to basket. I pass in a code, I return an observable of a basket. And this is how you would use it. You say, add to basket, passing in the code, that returns an observable, and you subscribe your basket observer from the UI. And that's it. This is the equivalent of our really simple async task. This is going to fetch on the background, deliver the result. So let's get fun. Let's mix it up a bit. First, discovery from that really beautiful API we work with. Well, we don't really have any HTTP code for errors, so every single time an error happens, it's just going to be a 200, and the JSON is embedding some form of error code or error message inside. So we have to deal with that. So how can we do it? So we go in your data layer. So we don't touch the UI. The UI still wants to do the same thing, just adding something to the basket and observing the result. So in our data layer, we can say, actually, I have adding to a basket, which returns the observable of basket, which is what I want to provide. But internally, adding to basket will return a response of a basket. So I can define my own model that is a JSON wrapping the potential error or the potential value. And that's what I have. I have a response of a basket, not a basket. So I can compose. I will compose in here something called check API success at the end of my call returning a response. And this somehow will transform it from a response to an actual basket. So the UI hasn't changed. Let's see how we do that. So we use flat map. We can provide an observable for each items coming through. Let's see why. So we're using Java. I decided not to use retro lambda because I don't want to make this talk confusing. So as you can see, there's a lot of verbose. We don't have first order functions. So all that code at the top, you can kind of ignore it at the moment. This is just a way to create a function. It's simple interface saying I have two types. So I pass in input, I get output, which is what you have here, input, output. So what's actually relevant is in here. And what do I say here? I say, if I have a response of a basket, and it is a success, then what I return is just the body. So I create an observable from one value, which is the body of my request. That was my basket. If it's not a success, I have a problem. So let's just say create a custom error, and observable.error will be an observable that fails straight away. And in here I'm saying, if it's not a success, I'm going to create my custom error and pass it through to the UI. And at this point, the UI has the on-error call, knows what to do, and can display a dialog for it. And that's it. I haven't changed my UI. I've added one function which defines what is a failure. And now I have handling the failure directly. My UI hasn't changed. I still get my updates as being full-blown basket objects, which is the easiest to display. And that's it. Next step. Well, actually, my API is not really returning to me a basket every single time. It's not stateless. It's returning a diff. So I have, in my app somehow, to compute that diff. I don't want to do that in the UI. So let's do it in the data layer. We add another step. We say a map, a transformation for each diff. I want to produce an updated version of the basket. I'm going to apply the diff to a function that I will define to the cached basket. So this here is your basket object that is cached in your data layer. Up to you to define how you want to cache it. You might want to either query it from a database, in which case you can be a bit more complex than that, or just simply have it in memory here. The idea is you will define in your data layer what is the latest state and how to update it. So map, function going from one type to another. This is how we define it. You can see here, I have a function that takes a diff and return a basket. How do I define it? Well, it's up to my model, really. At this point, a basket should know how to apply a diff. Or you could have another object that knows how to transform them. But in any case, this is now business logic. As long as you know how to transform a current basket with a diff to the new version of the basket, you're set. This method is going to be called every single time you get a reply and be able to transform it. OK, so now we have an API, checks if we have a success or a failure, then transform a diff to a full-blown basket, and we discover there's another problem. You know those nice little cards, like loyalty cards that you get, and you scan the barcode and you get some free stuff after 6 months and a half? So those things, apparently, if we send that barcode to the API, instead of adding the customer as a customer rewarding the points on this basket, the API is just going to return saying, hey, I know that customer. It's customer ID, whatever. If you want to add it, you do another API call. Because why do everything server-side, right? So now we have to deal with that locally as well. So how can we do it? So composition, flat map. And here we clearly defined I need to do an API call, then another one. And I'm going to call this add customer if needed. How do I define this add customer if needed? Well, in terms of the types, I don't really want to do a different type. I'm not changing the data. I'm just potentially adding a new step. So it's taking a diff and returning a task that returns a diff. So in here I say, do I require adding a customer? If I do, then add a customer with the diff. If not, just return the diff. And this add customer here is another method in your data layer that takes the customer ID and returns an observable of a diff. Exactly the same type of observable we've been building now for adding to the basket. It's another just component that returns a value. And in here, by returning it here, we chain them together. So now, in my UI, I still haven't changed. I'm still doing one thing. I'm sending a barcode to the API and expecting an updated basket. Now, sometimes it's going to take longer because it's going to do 2 API calls instead of 1. But I don't have to care about it. I'm just waiting for a reply. When the reply is ready, I get it. I can display the data. And the problems continue. Apparently, we're not supposed to sell alcohol to minors. Shocking. So we need a way, if we're selling alcohol, to display something asking for the user's date of birth. Now, the API decided, apparently, to treat that as an error. So our nice API is going to return to us when we try and add a bottle of alcohol with an error saying, I need more data. And up to us now to fetch that data, send it to the API to finally be able to add our item to the basket. Now, wait a minute. This is getting a bit more complex because I actually need, in the middle of my action, which was I want to add something to the basket, I need to ask information to the user. I need to actually display something like this. So how do I do that without having my UI having to understand what is that failure, what do I need to display, and the call I need to do afterwards? Because if I could make it generic enough so that tomorrow, when they ask me how to resume from another error, I don't need to change my UI again, that would be good. So let's add yet another step using onErrorResumeNext, because this time it's if I have that failure, I know what to do with it. And here we say check for error, passing a continuation of a code. So this is getting a bit more tricky. I'm passing in 2 functions, like a function that takes a function. So let's see exactly what that means. So I'm going to use onErrorResumeNext, which defines if I have an error, I'm going to tell you what to do. And this is what I'm defining. I have an error. I know how to resume to get you a basket. Now, if my error is a business rule exception, so this is me defining in here that if it's an error that I know how to resume from, this is how I called getting, like needing more data for a business rule, then I return an error customized with a continuation. If not, I just return. So what does that mean? That means I'm going to send to the UI an error that contains a function. And that function, you can see it here, a function continuation takes data and returns an observable of a basket. This is me defining when I call this, if you give me data, the piece of data I need, so this could be date of birth, for example, I'm going to return to you an API call. I'm going to return to you what to do. And this is how you could define your continuation. You could say, if I have data, what I need to do is call add to basket again, passing the barcode and the data this time. And if I do this, in my UI, I need to change something now because I do need to resume from it, but I can do it like this. Displaying a dialog from my error, flat map with my continuation extracted from the error. Wait a minute. Flat map? So displaying a dialog, I'm telling this is an observable of data. So yes, if you think about it, a dialog is exactly the same as an API call. It's something you do. You display that dialog, and you're waiting. You're waiting for the user to return to you data. You don't know if the user is going to cancel the dialog or not. You don't know when he's going to click the button and give you some data. You just know that at one point you're going to get it, or not. So it's the exact same thing. There's no need to treat the network layer and the UI layer completely differently. And in here, with continuation from, is just extracting the continuation from my error and then calling the function. Those two functions working together now allow me to define a generic way from my UI. If I give you an error and I tell you what type of data I need, I know how to resume myself. So this is a way you could implement reactive dialogue, as I call it, which is wrapping show to return an observable of t. This is actually part of a set of tools that exist called RxAndroid. And that dialogue is a piece that I submitted to the repo. There's a few other tools that can help you wrap some UI components or deal with some UI bits in Android in a reactive way. It's not like a standardized thing. It's just a collection of kind of tips and tricks that people have done so far. So it's pretty much a work in progress, but it's quite nice. So yeah, reactive dialogues. It's kind of crazy now. It's a complete different mindset of saying, I'm not going to use reactive programming or observable just for my data layer or just for my UI layer. It's a unified language to deal with values that come in the future. It's a way to create a pipeline of data in the most basic way possible. And what we have now, if you look back to it, for someone coming in the project now, what can he read if he wants to add something to the basket? He will read that adding to the basket is adding to the basket and getting a response, checking if it's a success or not, adding a customer if it's needed, applying the diff to transform it into a full-blown basket object, checking if it's an error, displaying a dialog, and continuing. All that is in one place. Everything that is relevant to that really complex API call that has loads of requirements behind it, everything is in one place. As long as those functions here are clearly named, you don't need to look at them anymore. You define them once, you isolate them. They're functions. They're static, they have no state, fully unit testable, no dependencies, no crazy mocks needed. You just test those functions using the real values and make sure they work perfectly. Once they're fully unit tested and properly named, you don't even look at them anymore. And you just have a set of tools to build pipelines that make sense. Reading all the logic around your API calls, around all the complexity that you have to deal with your different sources, your different APIs, is in the right place, in the data layer. Your UI cares about one thing, requesting data and displaying it. So that's it. We're happy we have a way to refactor and iterate over changing data models, changing data APIs, and make sure that we can keep all the craziness, all those composition and transformation of our models all in one place, in a data layer, isolated and fully unit tested, so that our UI has to deal with one thing, displaying it in the most beautiful way possible. So if you have any, if you want to learn more about some of the bits on Android, RxAndroid has some good collections. The effort has kind of slowed down lately, but hopefully the community is going to kick off again and we'll see some more nice tools around Android for it. I also created a simple pure Java workshop. If you've never done RxJava before, if you've never seen observables or functional programming before, it's an easy way to understand kind of the basic operators and transformations. So the things we've discussed today, map, flat map, resuming from errors, those are covered in this workshop. It's just a collection of to-dos in a big file with some pre-made operators and observers. And yeah, it's just a way for people to quickly play for a bit. Like in a couple of hours, you can go through it and have a better understanding on how it works. And then after that, I guess just up to you to have fun and play with it in your personal projects, I guess. Usual kind of self-promotion here. Nevoda, we're based in London, Berlin, Barcelona, Liverpool, even trying to extend to New York now. We're always looking for talented devs or talented designers, so if you're interested, feel free to contact us. We're happy to meet new people and get to meet as many people as possible. Yeah, any questions?